Okay, circles. Exercise 10.1. First one. How many tangents can a circle have? How many tangents it can? Infinite. Because at every point you can draw one tangent. For every point you can draw a tangent. So we have infinite points, so infinite tangents you can have. Okay. Tangents. So for at every point you can draw a tangent. So you have infinite points on the circle, infinite tangents you can draw. Okay. So exercise 10.1 circles. Now second main, filling the blanks. A tangent to a circle intersect it in dash points. How many points? 1 point. So we call it as a tangent when it intersects the circle at only 1 point. We call that as a tangent only when it intersects the circle at only 1 point. Okay. Second one. A line intersecting a circle in 2 points is called secant. Yesterday we studied, right? Correct. Secant. Third one. Next, a circle can have dash parallel tangents at the most. How many parallel tangents it can have? 2. So one circle is there. One I can draw this side. Similarly, here also 1 point will come on the other side. So I can draw 2 tangents. For 1 point, for one tangent and only one other tangent you can draw with this pattern. Like that, so many pairs you can draw. For one tangent, if I call this as AB, for this I can draw only another one tangent which is parallel to that. So like that, many pairs I can draw. But he is asking for one AB, how many tangents you can draw. Okay. So a circle can have dash parallel tangents at the most. We have, wait. Which one we are doing? First, second is done. Circle have dash parallel tangents at most. Most it can have. I thought that's one only, no? For one, yeah, you can have another one tangent as a parallel. So one tangent. I thought that is the meaning. Tangent. As a pair, it can be only one. No, that's what. Yeah. Okay. Or one pair or two, like that you write. 2 tangents. The common point of tangent to the circle and the circle is called point of contact. Third question. A tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at point Q. So that OQ is 12 centimeter. Length of PQ is a tangent PQ. PQ is a tangent to the circle. Okay. We'll draw. So P and this is Q. PQ is a tangent at a point P of a circle of radius 5 centimeters. So this is 5. It meets a line through the center O at point Q. So OQ is 12 centimeter. Find PQ. PQ is this. Q is this point. Pythagoras theorem. So this is 90 degree. What they have given, a PQ is a tangent at a point P of the circle. So point P is this. And the radius is 5 centimeter, meets a line through the center O at point Q. So OQ they have given. So OQ is equal to 12 centimeter. Find the length PQ you should find. What I have to use? I have to use the Pythagoras theorem. Why 90 degree will come? Always the radius and the tangent at the point of contact, it is 90 degree. See, this is the radius. Okay. PQ is the tangent. OP is the radius, PQ is the tangent. So at the point of contact P, it will radius and the tangent will make 90 degree. Always like that. Okay. So in triangle OPQ, in triangle OPQ, 90 degree opposite is the hypotenuse. Always 90 degree opposite is the hypotenuse. So OQ square is equal to OP square plus PQ square. Okay, OQ is what? 12 square. So that is equal to OP is 5 square plus PQ you should find. 12 square is what? 144 minus 5 square, it is 25. What you will get? That is equal to PQ square. So how much you will get? PQ? So PQ is equal to root of 119. If you are not getting a perfect square, it's fine. Root of that you can keep it. So which option is that? D is the option. And this type of question they ask for 1 mark only, they will ask. Draw a circle and two parallel lines to a given line such that one is the tangent, other is the secant to the circle. So if I draw this, this is a diameter which is passing through the center. So tangent will be, this is a tangent. So I mark this as PQ. Secant. So these two are parallel. XY is a secant which intersect the circle at 2 points. So XY, it is a secant. And PQ, it is a tangent. So tangent is the one which touches the circle at only 1 point or intersect the circles at only 1 point. Secant is the one which intersects the circle at 2 points. And this, if I call this as AB, AB is a diameter because it is passing through the center. And it is also the chord which is the longest chord of any circle. Diameter will be the longest chord of any circle. Okay, so chord means what? It from a line drawn between the 2 points of the circle will give you the chord. So diameter is the longest chord of the circle. Here I can write XY is parallel to P. Okay. Next, number of tangents from a point on the circle. Activity, I think. These are not fine. We'll go with the theorem 10.2. Listen now. Any theorem you are proving. Okay, listen. Any theorem it is proving. How you have to write is, first you should write the statement of the theorem. Diagram should be there. What is given to prove that, what you have to prove, then the proof. In the proof, what and all you are using, that you have to write it in the bracket. Don't write like I'm using theorem 7.1. Don't write like that. You should write the statement of that. Okay. If you write like that orderly, they will give like 3 or 4 marks, full marks they give. Again, I repeat, say any theorem if you want to prove, first you should write the statement of the theorem, then the diagram. So what is given the data in that to prove that what you have to prove, then the proof. In the proof, when you are proving from how it came, by some theorem or some given data like that, that also you have to write properly. Okay. Theorem 10.2, we prove this, right? The lengths of tangents drawn from an external point, to a circle are equal. Okay. The lengths of the tangents drawn from an external point to the circle are equal. This is important one. Okay. So from one external point, we are drawing the tangent to the circle. From one external point, we are drawing the tangents to the circle. So external point, I will mark it as P. We have PQ and PR. PQ and PR, they are equal. You have to prove that PQ is equal to PR. Again, I repeat, a tangent means the line which touches the circle at one point, that is intersect the circle at one point, we call it as the tangent to the circle. So from one external point, here I have taken as P. From external point P, we will draw two tangents to the circle. You have to prove that the lengths of the two tangents are equal. Okay, so here we use the congruency of the triangle to prove that. If I'm drawing the triangle here, if I'm trying to draw the triangle, Gavin, what is that? O is the center of the circle I've taken. I will join OQ and OR. Okay, OQ and OR. If I prove PQO triangle and PRO triangle, if these two triangles, if I prove they are congruent, then by CP/CT rule, I can say PQ is equal to PR. Okay. So in this triangle, OQ and OR is what? They are the radius of the circle. They will be equal. And OP is the common side for both. So it should be equal. And we have this angle. This is 90 degree. So this is also 90 degree. Why it is 90 degree? Because the radius and the tangent will make 90 degree angle. So by all these given data, we can prove that the two triangles are congruent. Okay. Hmm. So given consider a circle with center O. With center O. Okay. P is a point outside the circle. P is a point outside the circle. PQ and PR are tangents to the circle. So to prove that PQ is equal to PR. Okay, construction means join OP, OQ and OR. Okay. So first what we have considered, we have considered one circle, one center O. From point P, which is outside the circle, PQ and PR are tangents to the circle. Now we have to prove PQ is equal to PR. Construction means we're just adding the extra lines, that is joining OQ, OR, OP. Okay. In triangle OPQ and OPQ and ORP. OPR. OP is equal to OP, common side. OR is equal to OQ, radii of the same circle. So they are the radius of the same circle. They should be equal. OQ is equal to OR. OP is equal to OP, common side. Then PQO angle is equal to PRO angle, that is equal to 90 degree. What is the reason? This is equal to this. Because radius and the tangent are perpendicular to each other. Tangent are perpendicular to each other at the point of contact. At the point of contact. Okay, so that is therefore triangle QOP is congruent to triangle ROP by RHS congruency rule. Why RHS congruency rule? 90 degree. It's right angle. Both are right angle triangles. That's why we use RHS congruency. Okay. For by CPCT rule, PQ is equal to PR. PQ is equal to PR. Okay. So congruent means what? One triangle is exactly same as the other. Similar means only the shape of that will be same. Size need not be same. But in congruency, it is both will be the exactly same. That is photocopy of the other. One will be the photocopy of the other. If you take one triangle, draw one triangle and take the xerox of that, they will be exactly the same, right? Then those two are congruent. But similar means the shape is same, but size need not be same. Prove that in two concentric circles, the chord of the larger circle, okay, which touches the smaller circle, is bisected at the point of contact. Right. And in circles, all the examples, all the proofs are very much important. All these are important. What is that people are discussing? Prove that in two concentric circles, the chord of the larger circle, which touches the smaller circle, is bisected at the point of contact. So, first thing, two concentric circles. That means what? Two circles will have the same center. Then they are called as the concentric circles. If the two circles will have the same common center, then they are called concentric circles. Now, chord of the larger circle, which touches the smaller circle, is bisected at the point of contact. So, AB is a chord to the circle, to the bigger circle. If I call this as C1 and this is C2. Okay. AB is the chord of the larger circle, but AB is the tangent to the smaller circle. See, AB is the chord to the circle and it touches the first circle. That means what? AB is a chord for the second circle and AB is the tangent for the first circle. Now you have to prove that a perpendicular drawn, okay, OP is the OP is the radius. So that will divide the chord into two equal parts. You have to prove that there it will divide the chord into two equal parts. Okay. So first thing, AB is the chord for the first circle. This is the larger circle, and AB is the tangent to the inner circle. Okay. And OP is the radius of this circle. So, and it is made a tangent at point P. Okay. OP and AB will make an angle of 90 degree. So, OP is a perpendicular drawn. Okay. It makes an angle 90 degree for AB. Now, in the 9th standard, we had studied a perpendicular drawn to the chord of the circle will divide the chord into two equal parts. So, we'll use that. So, what we studied, a perpendicular drawn from the center of the circle to the chord will divide the chord into two equal parts. So, from that, we can see AP is equal to P. Write down the theorem now. Not the theorem, example. Write down this. Write down this. Write down this proof part. Remaining what we have to write. AB is the chord of the larger circle. Larger circle. Therefore, AP is equal to PB. What is the reason? Perpendicular drawn from the center of the circle, to the chord divides the chord into two equal parts. Divides the chord into two equal parts. Okay, so this is the proof. Bisects the chord. That also. or instead of this, you can write bisects the chord. Same meaning, bisects the chord. What is that? Hmm. Shh. Hmm. Talk fast and keep up. Okay. Huh. Example to everyone do. See, tell your friends not to call in the tuition time. Maybe emergency, but parents calls, it's fine. Okay, everyone. Hmm? Example two or switch off your call. Yes. Example two, two tangents. Okay, prove this everyone and come and check. Two tangents TP and TQ are drawn to a circle. Are drawn to a circle with center O. With center O from an external point. From an external point T. Prove that PTQ is equal to 2 times OPQ. So first one circle from external point P. This is point T. Okay. One point P and this is Q and this is the center O. Now OP. Ah. Q. Okay. Now you have to prove PTQ. This angle is equal to 2 times OPQ. And what and all data we have, by that we have to prove this. Prove that. See, any proof, new proof also, if they are asking everything, concept, what and all we have studied, with that only it will come. Nothing new, more they will expect. But they would have some twisted question they will ask. Okay. Listen now. So given TP and TQ are tangents from external point T. Okay. Now what you have to prove? To prove that OPQ, okay, is equal to or 2 times OPQ will be equal to PTQ. I have to prove. Okay. So what and all is given here? Given, consider a triangle, a circle with center O. Okay. So TP is equal to TQ. Listen here, TP is equal to TQ. They are tangents from the same external point. Tangents from same external point. Okay. So this much is a given thing. Now, proof. First thing, what I have to prove? OPQ, I have to find the relation between OPQ and this angle. Okay. So what is first OPQ equal to? OPQ will be equal to 90 minus of TPQ, correct? Or is equal to 90 minus TPQ, this angle, 90 minus this. Because why? OP, reason is OP perpendicular to TP. Okay, again I repeat, see, OPT is 90 degrees. I want to find about OPQ. So OPQ is what? 90 minus this. So 90 minus TPQ. Okay. Next, 90 minus TPQ is equal to this angle. Now, if you write this TPQ in terms of this, I'll get the relation. Okay. Now, in triangle TPQ, if I consider this as theta, y is considered, it looks easier. That's why it's given this as theta. Okay. So, angle theta plus TPQ plus TQP. This is equal to 180 degree. This plus this plus this, all the three together in a triangle, it should be equal to 180 degree angle sum property. And TPQ and TQP, TPQ is equal to 2TQP. Why? Because TPQ is an isosceles triangle. Because why isosceles triangle? TP and TQ are lines, they are tangents from external point, they are equal, we know from the theorem. So TPQ is an isosceles triangle. So therefore this angle TPQ and TQP, these two angles will be equal. Okay. Now I know this this angle is equal to 90 minus this. So if I write this in terms of this angle, I can get the relation between this angle and this. Okay. So I know 90 minus TPQ is OPQ. Now what is TPQ? I have to find in terms of theta. So theta plus TPQ plus TQP, it is 180 degree angle sum property, and these two angles are equal. So instead of this angle, I can write this only because they are equal. So I can write theta plus 2 times of TPQ is equal to 180 degree, or theta is equal to, or TPQ is equal to. Yes, can like just one easier. You can write like that. Same thing, only instead of that, they've just given the name. So TPQ is equal to 180 minus theta by 2, or 90 minus theta by 2. Now, instead of TPQ here, if I write this as equation 1, instead of TPQ, you substitute this, you will get the answer. That's it. Right. See, what we have done is, this plus this is 90. So OPQ is 90 minus of TPQ. So I will write TPQ in terms of this. Okay. So for that, I'll take this triangle. In this triangle, two sides are equal. So TPQ and TQP, they are equal. And angle sum property, theta plus these two angles is equal to 180 degree. These two are equal. Instead of TQP, I will write TPQ only. So theta plus 2 times TPQ is equal to 180 degree, or TPQ is what I have to substitute. So that is equal to 180 minus theta by 2. That is 90 minus theta by 2. Now here you substitute, you will get the answer.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.